In a library, there are 210 math books and 55 science books. There are various racks wherein equal numbers of books are required to be kept. So what is happening here is you have a rack. Okay. You must have seen in the library there are these various columns, and then there are various books which can be kept in each rack. So let's say each one of these represent a rack. A librarian has 210 maths books and 55 books, and they need to be arranged in each of these racks. Okay, so let's say some here, some here, some here, some here. The condition is that the number of books in rack, let's say if I call this as A, B, C, D, the number of books in all these racks which are required to be kept has to be equal, right? The librarian wants to arrange them in a manner that they take minimum number of racks. The minimum number of racks can be happening only when we use up the maximum area of each of the racks, right? But the second condition is that whatever books we keep in one rack has to be equal. What number can be put in each of the racks, right? And how do you resolve this? We resolve this by finding out the highest common factor of the maths and the science books by using the Euclid's division algorithm. So we have 210 maths books and 55 science books. Now 55 would go into 210 three times, and we will get 165. Subtract this. Okay, and you will get 45. If it was to be expressed in the form of a lemma, you would have written 210 is equal to 55 times 3 plus 45. Now we will divide 45 by 55. Okay, this will be one time, right? Or in other words, we can write 55 is equal to 45 times 1 plus 10. 10 is the remainder. Next step, 45 is now to be divided by 10 for 45, right? This could be written as 45 is equal to 4 times 10. Actually, it should be the other way around. Plus 5, and then we divide 10 from 5, and you know the good thing is what? This time we get a 0. 5 times 2 gives you 10, 10 minus 10 gives you 0, right? Or the highest common factor is what? 5, right? For the sake of completeness, I just write this as it is. Which means what? That for each of these racks we have to keep 5 books, because if we keep more than 5 books, okay, then probably we may end up in one of the racks not having the equal number of books. So let me give you an example. Let's say for example we have 55 books. If you start keeping 6 books in each rack, what will happen? You will have 6, 4, 5, 6, 7, 8. 6 times 8 gives you 48, and then 9, and then in the last track you will be left with only one book, right? Which is not what we want, because we have been told that the books which are required to be kept have to be equal in all the racks, right? Therefore we cannot have 6 books, or for that matter 7, or for that matter 8. It has to be 5, because when there are 5, then all the science books effectively will get covered in, let's say 55 books are there. You have 5 books in each rack. You will require 11 racks, and all the science books will be placed. Similarly, for maths, if you have 210 books, divide by 5, it's equal to 42. So in 42 racks, all the math books will be kept. And they will be all equal, because there are 5 books for maths and 5 books for science in each of the racks.